Alaikum. My name is Siraj Al-Ghamdi from section JA4, team 1. Today in this presentation we'll talk about fusion welding. In the next slide, fusion welding is defined as the melting together and fuse materials by the use of heat. Heat supplied by various means. This is what we will be talking about in this presentation, which is oxyfuel gas, arc, and high energy beam welding process. In the next slide, we have the oxyfuel gas welding. Is a general term used to describe any welding process that uses a fuel gas combined with oxygen to produce a flame. The most common gas welding process uses acetylene. The process is known as oxyacetylene gas welding and is typically used for structural metal fabrication and repair work. The primary combustion process, which occurs in the inner core of the flame, involves the following two reactions, as you can see. And we have here in the picture, we have the gas mixture enter the welding torch and generate a flame and melt the metal. In the next slide, we will talk about the flame types. The proportion of acetylene and oxygen in the gas mixture is an important factor in oxyfuel gas welding. At a ratio of 1 to 1, no one should exceed the other. If the oxygen exceeds the acetylene, we call it oxidizing flame. If the carburizing flame, in the carburizing flame, the acetylene exceeds the oxygen. The filler metals are used to supply additional metal to the weld zone during welding. They are available as filler rods or a wire and may be bare or coated with flux. The purpose of the flux is to retard oxidations of the surfaces of the parts being welded by generating a gaseous shield around the weld zone. The flux also helps to dissolve and remove oxides and other substances from the weld zone. In the next slide, oxyfuel gas welding can be used with most, we'll talk about the practice and the equipment and the pressure gas welding. Oxyfuel gas welding can be used with most ferrous and non-ferrous metals for almost any work-based thickness, but the relatively low heat inputs limits the process to thickness of less than 6 millimeters. The equipment of oxyfuel gas welding consists basically of a welding torch connected by hoses to high pressure gas. Consists basically of a welding torch connected by hoses or to high pressure gas cylinder and equipment with pressure gas. In the next picture, we have basic equipment used. The basic equipment used in the is all in the picture. So pressure gas welding, in this method, the welding of two component states with the heating of the interface by means of a torch using an oxyacetylene gas mixture. Now we will be moving to continue with my teammate Khalil.
Assalamu alaikum, my name is Khalil and I'm going to talk about arc welding. Arc welding is welding, but instead of using gas, we are using electricity. Okay, so in order to have arc welding, we must have welding machine, and we must have an electrode, and we must have the workpiece, as you can see in this picture. Now the welding machine is used as the source of power for the electrode to establish arc, so we can do the arc welding on the workpiece. And as you can see, the workpiece is where we can work and use the electrode on it. Okay, so this is the base. So these are the basic components of arc welding. Now there are other types of arc welding, such as consumable arc welding and non-consumable arc welding, which I will now. But you have to know that the basic difference between them. Consumable arc welding is that what basically happens is that the electrode itself becomes part of the workpiece. A very significant part of the electrode becomes part of the workpiece, As for non-consumable, that does not happen, which I will explain which I'll explain later. But now that I have explained the types and the definition of arc welding, I would like to discuss the advantages and disadvantages. Now, for arc welding, as you can see, there are not many parts for it, so the cost for the equipment will not be expensive, and the equipment will be easily transferable. And due to the high temperature needed for the electrode to work on the workpiece, shielding will not be necessary. So you can put it in any environment, and it can still you can still do arc welding. As for the disadvantages range from most of the arc welding. When you finish, it kind of leaves marks and on the workpiece, and other than that, it requires a very high skill. As for the application, let's move on to the next slide. As for the applications, as I talked about consumable electrode and non-consumable electrode, as you can see, and the flux cord arc welding is a consumable electrode. As you can see, the electrode that is applying the work is actually becoming part of the molten metal. Also, for the non-consumable electrode, as you can see, the plasma arc welding is basically plasma gas that is working with a tungsten electrode, and as you can see, the tungsten electrode is not representing a huge part of the metal that is being worked on. So as you can see, when the force of the plasma gas and the tungsten electrode is applied down, there is also shielding gas that covers the workpiece from being deformed by oxygen, as we know that oxidation strongly influences the shape of the metal. Moving on to my friend Muhammad.
Hello, my name is Mohammed Busati, and I'll be explaining the electric beam welding. In this process, first we defined it as that the kinetic energy in the electrons are turned into heat and by striking the workpiece. There is several three type of electric beam welding based on the vacuum. The first type is the higher the vacuum, the more the beam penetrates, and the depth of and depth to weld ratio is greater, and that is called the higher electric beam welding. The second type is medium electric beam welding, and the last type is non-vacuum electric beam welding. It is a specific type where some metal does not need a vacuum. Some workpieces doesn't need a vacuum to work on it. The advantages of this process is distortion and shrinkage is very minimal, and the weld has a very high priority. One of the disadvantages of this process is that it generates X-ray, which make it very harmful, and should be very safety precaution around it should be very high. Its application varies between typical application include welding of aircraft, missiles, and the nuclear weapons. Next, I'm gonna move to laser beam welding. In this process, first of all, we don't need a vacuum, and we can define it as utilizing a high power laser beam at the source of heat to produce function weld. fusion weld. I'm sorry, to produce fusion weld. A type, there is three different types. First, gas laser. Second, solid laser, and eventually fiber laser. The characteristic of the laser beam welding, first of all, the ratio of heat and cooling is high due to the power density of laser beam. Second, the, the operator skill required is minimal. Eventually, we go to the application. It is used in area where a large value of production is required. It has several advantages over electric beam welding. Mainly the fact that it does not require a vacuum. Finally, I'm gonna move to cutting, and cutting is divided by two sections: oxy-fuel gas cutting and arc cutting. Both those sections were explained in the welding area, oxy-fuel welding and area cutting welding. It's a similar process, however, the difference is here the heat generated is meant to cut through the workpiece rather than weld it. Uh, in the oxy-fuel cutting, we need to focus on the purity of oxygen, which should be 99.5%. Second, we need to focus on the fuel gas to oxygen ratio, heat of combustion, which is meant to focus on the type of fuel uh, combined with the oxygen. In the last one, arc cutting, we can divide it by two sections: air carbon cutting and plasma cutting. The plasma section is very high production, has very high quality, and also uh, has very small mistakes, and develop a very clean piece. Next, I'm gonna move to my friend uh, who will explain the the welding joint. Saud.
Hello everyone, I'm Saud Hashim, and today I'm going to talk about welding joint, fillet welds, and quality of welding. To begin with, welding joint. A welding joint is a point or edge where two or more pieces of metal or plastic are joined together. They are formed by welding two or more work pieces, metal or plastic, according to a particular geometry. There are five types of joint referred to by the American Welding Society, corner, edge, lap, and T. This configurance may have various configurations at the joint where actual welding can occur. Second slide, fillet welds. A fillet welds joins two surfaces at an approximate right angle to each other. There are several types of fillet weld. Full fillet weld is a weld where the size of the weld is the same as the thickness of the thinner object joined together. Staggered intermittent fillet weld refers to two lines of intermittent welding on a joint. An example is a T-joint where the fillet increments that are in one line are staggered and comparing to the other line. Chain intermittent field weld refers to two line of intermittent field weld in a lap joint or T, where the weld in one line are and approximately opposite those in the other line. The second slide. Finally, quality of welding. The following are typical requirements for the quality of weld products. The product is finished accurately in accordance with the design dimensions. The product offers the required functionality and the strength or safety. The appearance of the weld satisfies the required level. And thank you for listening.
In the references, we got all of our information from the book, as we can see. Next, thank you for listening. Was with you section from section GF4, team 1, Siraj Al-Ghamdi, Khalil Salman, Muhammad Busati, and Saud Hashim. Thank you.